Okay, so my name's Robert Thompson. I work for Freescale Semiconductor. So I think most of us are here because we're trying to answer this question, or we're thinking about this question. Which one of these wearable devices will sell the most? I have no idea. So you're probably wondering why I'm standing up here and you're sitting down there. The reason is because I work for a semiconductor company, and we don't make finished products. What we do is we try and supply components into as many of those products as possible. So from our perspective, what we started hearing about a couple of years ago from many of our customers was this word wearable. But it was very badly defined. When we tried to dig down, most of our customers really didn't know what usage model or what target market they were going to. But they were coming to us as a semiconductor company to use our base products, be application processors, microcontrollers, but ask us, who should we partner with? How should we go to market? So what we decided to do was to try and help that process along. As a semiconductor company, we're not going to make a finished product, but what we want to try and do is to make the path to market for our customers as productive and as fast as possible. So to do that, we decided to come up with a reference design. If you're not familiar with a reference design basically takes the core products and surrounds them with our partners' products, builds a board to help you, our customers, not have to do all the basic work of sourcing the right components, building a PCB, finding the right operating system. We want to try and do all of that for you, so you can simply take that, test your concepts, prototype, and get to market as quick as possible. So in the wearable space, what we looked at, and we said, what are the key characteristics? What do we need to achieve to help people design wearable products? Well, obviously, form factor was critical. It had to be as small as possible. We had to maximize battery life. It had to be connected in many different ways, and obviously usability was key. Now remember, this was two years ago, so the wearables market was even more vague than it is today. But what we found was, regardless of the customers we spoke to, regardless of the market, these were the 4 areas that we had to try and come up with a solution to be successful and to help our customers get there. So what did we do? So I apologize now if you're not too technical and a block diagram turns you off, but stay with me and hopefully you'll find this a little bit relevant. So this is what we've come up with. It's called the Warp Board. We have a website that has been active for a while, warpboard.org, and we are actually announcing today the availability of this product, which I'll show you at the very end. What we did is we obviously based it on our technology. It's based on a Cortex A9 single-core application processor that was originally designed for the e-reader market, so it's very low power, has very long standby time, and maximizes battery life, all key characteristics of any wearable device. We then partnered with a number of different companies, over 20 partners, to get this product to market. So on the memory, which is obviously critical, we partnered with Micron for a combined flash and low power DDR2, 4 gigs of each. On the power management side, we actually didn't use our own power management. We partnered with Maxim because the Maxim product supported both a standard LCD display, but also an e-ink display. So if we looked at the many different usage models, e-ink, some of you might be interested in using that kind of panel for very long battery life and low energy. We support both a standard LCD and an e-ink display, so you can prototype with both these different displays. We included a 6-axis accelerometer, which is both an accelerometer and magnetometer. And from a connectivity standpoint, we partnered with Murata, which has a Wi-Fi, Bluetooth low energy combo module. Now that's the main board. And on that main board, we've given you all the major components you would need of any wearable device. This main board is 38 by 16 millimeters. It's a 10-layer board with blind and buried vias, if you're familiar with PCB fabrication. It's a very complex board, but we've done it for you. So you can take this and run with it and test your prototypes. It runs Android 4.3, which we've modified to run on a 1.5-inch LCD. So from a software development standpoint, you'll have Android available to you. It uses the standard Android SDK and APIs, so you can take an application that you've developed for a larger screen, run it on this. Obviously, you'll have to make some modifications, but once again, you might not want to use Android, but you can prototype your software very quickly because this is standard Android running on this device. Now, the challenge with wearables, as we know, is wearables is so broad. In a reference design, how do you attribute or how do you look at the many different usage models? So this is the main board. Then what we did to attack these many different usage models that we believe already exist and going to evolve in the wearables market, we attach a daughter card. So this is a much simpler device. It's a 2-layer board that has a an overall cost of around $10. As you can see from the number of blocks on the diagram, it's much simpler. What we've done here is the first daughter card uses an accelerometer with a pedometer algorithm, so you can test simple activity tracker use cases. That data is then stored in an MCU, which acts as a sensor fusion device. Now, all of the choices here of all the components, we've worked with many partners, we've looked at the market, we've selected them all for obviously small form factor, but obviously low power. So in terms of the challenges that any wearable product faces in terms of maximizing battery life, we've done a lot of the work for you, which is what we're trying to achieve here. We're trying to accelerate your development of any wearable device. In one of the keynotes earlier today, we talked about battery life and wireless charging, where we're also giving you wireless charging. As you can see from the diagram on the bottom there, we're giving you a wireless charging coil. Freescale has a Qi-compliant software stack, which we ported to the sensor hub. So you can again, by buying this, you can experiment with different battery lives, different usage models around wireless charging. It will ship with a 350 milliamp battery, but we will also make other batteries available depending on your usage models and how you're looking at entering into the wearables market. As you can see at the bottom there, this all stacks together. It will ship with a standard 1.5-inch LCD with touch module integrated. That sits on top of the main board and the battery. The daughter card that you're seeing here and the wireless charging coil sits beneath it. Now, when we were looking at this market, what we saw was a market that's rapidly innovating and changing. So we said, how can we really keep up with this innovation? We're one company partnering with many. So what we decided to do was we decided to open source this project. So on the website, which is active today, we will publish not only all the design files, schematics, Gerbers, we will list the BOM. So we will show you exactly all the components we used to make this product. On the software standpoint, it's Android, so it's open source. We will have a purely license-free version of Android, and we will have another version of Android that does require a click-through license, but no royalty fees. So this will now become available for $149. For $149, you get what we're showing you, and because it's open source, you can take it and do what you like with it. If you want to work with us, you can. If you simply want to take it and design it for your own purposes, you're more than willing to do that. So what are we doing here? To make a quick comparison, and I might lose some of you, but you might have heard terms like Raspberry Pi, Arduino. If you look at reference designs, what we're trying to do with the Warp board is really straddle the maker and the hobbyist community and also tier 1 consumer electronics companies. So if you look at Raspberry Pi, Arduino, if you're familiar with them, they're great products, but they're not specifically designed for the wearables market. If you've ever used them, they're small, but they're not anywhere near as small as you need for a wearable product to be. The Warp is. We're 38 by 14 millimeters in our main board, slightly larger when we add the battery. Obviously, we're focused on battery life. As I mentioned, all the components that we chose were focused on low power. We borrowed a lot from the smartphone world. In terms of scalability, we have the main board and the daughter card. We plan to come out with other daughter cards based on other usage models as the project evolves. However, it is open source, So we're looking for the open source community to give us ideas and develop their own daughter cards. The cost, as I mentioned, is $149. It's an open source project. The reason it's open source is because we want you to get to market as quick as possible. And that's what Warp is all about. We're trying to help you take your idea, turn that concept into a prototype, and then to market as quick as possible without any barriers. So, to sum it up, what are we trying to do? Well, Wearables is all about the future, but maybe by looking back, we see somebody who had a vision way beyond any of us. So, if you were at the conference yesterday, you saw this slide, and full disclosure, I'm stealing it from the great keynote at the end of yesterday from the US Olympic Committee, where he showed this slide and it really resonated. So if you had an hour to come up with a wearable product, what we're trying to do is make the most of those 55 minutes that you're using to come up with the right questions. Warp is all about giving you the right tools to come up with the right ideas and get to market as fast as possible. So how can you do that? Well, this product is now available. So you can go to thewarpboard.org, you can go to the Where to Buy tab, and you can pre-order it today. I think it went live about an hour ago.
And you can go by the booth.
And thank you. Am I running out of time? I thought I was well under 10 minutes. Anyways, and thank you. At the back, I was going to be facetious and hold it up here and say you can see how great it is. We have a booth back there. We have a sample of the product. My colleague is much better looking than me, so it's worth a trip, I assure you. Thank you for your attention.